All right, so we are going to work on our second day of adding and subtracting rational expressions. Before we get into the more complicated addition and subtraction questions, we're going to look at these two as a warm up. So go ahead and pause the video, try these two without me, and then we'll come back together and see how you did. So neither of these have a common denominator. So I need to get a common denominator. This one here, they both need to have a k, and the least common multiple of 3 and 5 is 15. So I need to get both of these denominators to 15k. So I'm going to multiply this one by 5k. I'm going to multiply this one by 3. And I'm going to show you how I personally do these. If you want to keep them in two fractions first, that's totally fine. But I like to rewrite them as one big fraction as soon as I have my common denominator. So I'm going to rewrite this as one big fraction all over 15k. So my first numerator, I had to multiply by 5k, and that was 2k minus 6, minus, I'm multiplying my second numerator by 3, so that's k minus 4. So now I'm going to distribute. So this would be 10k squared minus 30k from my first set of parentheses. I'm distributing a negative 3 here, so I have to make sure I remember it's a negative 3, which is going to turn that into plus 12, and that's all over 15k. So I have 10k squared minus 33k plus 12 all over 15k. Checking all of my coefficients and my constant, they do not all have a common divisor. There's no common number that I could divide out of each of those numbers, so we're done. Here in this one, common denominator is going to be 6a, so this one needs to be multiplied by 6. This one needs to be multiplied by a. So I'm going to have 6 times 5 from my first numerator and a times 4 from my second numerator. And that's all going to be divided by 6a. So that's going to be 30 plus 4a, all divided by 6a. Looking at 34 and 6, they're all divisible by 2. Sometimes it helps to see that factored out. So those 2's will cancel out to 1, so I'll be left with 2a plus 15 over 3a. So those are our warm-up questions, just getting our brain ready for day 2 of adding and subtracting. So here is our first more complex example. So looking here, 9 times out of 10, if your denominators are a binomial or a binomial and a monomial like this, 9 times out of 10, your least common denominator is going to be just multiplying them together. So here, and I'm going to just write these out for the first couple problems so you kind of get used to it in your head. I'm going to take x times x plus 3. And I'm not going to distribute this. I'm going to leave it like that so that I can clearly see what's missing from my denominators here. So this one is missing the x piece, so I'm going to have to multiply this first one by x. This is missing the x plus 3, so I'm going to have to multiply this one by x plus 3. And again, if you want to keep this in two separate fractions until you've done your distribution, that's totally up to you. This is the point where I just go straight to one big fraction where the denominator is my common denominator, and then I have it broken up first fraction, second fraction. So my first fraction I multiplied by x, and the numerator of that was x plus 4. My second fraction was a 6, and I'm multiplying that times x plus 3. And the sign is subtraction, so I'm going to leave the minus there. Now I'm going to distribute. So I have x squared plus 4x minus 6x minus 18. And that's all divided by x times x plus 3. That's going to turn into x squared minus 2x minus 18 divided by x times x plus 3. Now comes the fun challenge of figuring out if I can factor the numerator or not. Well, I would have negative 18 that we're trying to multiply to get, and I'm trying to add to get negative 2. Well, my factors of negative 18, I have negative 18 times 1, negative 9 times 2, negative 6 times 3. None of these combinations are going to add to get me negative 2, so that tells me we're done. All right. Here, my common denominator that I'm aiming for is going to be x plus 1 times x minus 1. I can't make it any more simple than that. Let me focus this a little bit more. So my first fraction has a denominator of x plus 1. That tells me it's missing the x minus 1 piece. So I'm going to have 3 times x minus 1 from my first fraction plus 4 times, denominator was x minus 1. It's missing the x plus 1. And that's all going to be over x minus 1, x plus 1. However you choose to write your denominator, you could write it backwards. Literally doesn't matter. Multiplication is commutative, so that means the same thing. That's going to turn into 3x minus 3 plus 4x plus 4 all over our common denominator. And then I'm going to combine my like terms in the numerator. So I'll have 7x plus 1 all over my common denominator. That's as simplified as I can make it. So we're done. All right, let's see. For our next one, now in this case, sometimes what we need to do is factor our denominator a little bit to see if there's any piece of the second denominator already living in our first denominator, or vice versa. So if I look here, I can rewrite this denominator as 3 times r minus 2. Because 3 times r gives me 3r, 3 times negative 2 gives me negative 6. So there's this 3, and I'm going to cross this out just so we remember I already factored that. This 3 is actually already in both denominators. So my least common denominator is actually going to be this first denominator on its own. So the first numerator isn't going to change at all because I already have that common denominator here. Now the second one has 3, but what it's missing is this r minus 2. So I needed to fix this denominator to look like that by multiplying by that r minus 2 that was missing. So again, the 3r plus 5 does not change. And then I'm going to have 4r squared minus 8r. So I'll have 4r squared minus 5r plus 5. And again, I just need to double check and see if I can factor the numerator. So I'm multiplying to get 4 times 5, which is 20, and I'm adding to get negative 5. Well, I have a positive that I'm multiplying and a negative that I'm adding to get. So that tells me both of these factors would have to be negative. So I would have negative 20 times negative 1, definitely not. Negative 10 times negative 2, not going to work. And negative 4 times negative 5, also not going to work. So we're done. All right, go ahead and pause and try this one without me. This one, you have two denominators that are binomials, so your easiest method for getting this answer would be using both in your denominator. So go ahead and hit pause, and then I'll show you the work that I did for this question when you hit play. So looking here, I already have this one all worked out on a separate sheet of paper, so I'm just going to zoom in and focus. There we go. All right, so this was my common denominator. So my first fraction was missing m plus 2, so I multiplied that. My second fraction was missing m minus 3, so that was multiplying here. Now I was distributing a negative 2m, so I had 5m plus 10 from my first fraction, negative 2m squared plus 6m from my second fraction. And then I have negative 2m plus 11m plus 10. That does not factor. If you're looking at your T-chart, you're multiplying to get negative 20 and adding to get 11. So again, I would have 20 and negative 1, 10 and negative 2, and then 5 and negative 4. And none of those will work. So that's as simplified as we would get. All right, zooming back out. Here is another one where your common denominator is going to be both of these just multiplied together. So again, go ahead and hit pause. And when you come back and hit play, I'll show you the work that I did for this one. All right, so zooming back in, try not to make you sick, sorry. So my common denominator is both of these multiplied together. My first denominator was missing n plus 1, so that tells me what I need to multiply my numerator by from my first fraction. The second fraction was missing n plus 1, or excuse me, the first fraction had n plus 4. The second fraction has n plus 1. I'm missing n plus 4 here. So I multiplied my first numerator by n plus 1, my second numerator by n plus 4. Here's my distribution. Now you'll notice that these 6 n's for my linear term cancel out to 0, and I'm left with 6n squared minus 24. So this, because this is one of my special case factoring lookalikes, what I did was I noticed that 6 and 24 both have a common factor of 6. So I need to factor out that 6 and see if I can go any farther. Our answers are always going to be as simplified as possible, which means we are going to have to factor as much as we can to see if there's any common factors in the numerator and the denominator. If there's not, we just leave our answer as its simplified factored form. So n squared minus 4 is one of my perfect square factoring scenarios. Excuse me. So that would be n plus 2 and n minus 2. In this case, nothing in our numerator or denominator will cancel out and make 1. So I just leave it as it is, and that's my simplified answer. All right, here is our next one. There we go. Focus it up a little bit better. So in this case, this is another one where I'm going to factor my first denominator as much as I can because I noticed that 16 and 8 have a common factor. So I'm going to rewrite this as 8 times 2n plus 1. Now there is a 2 hiding inside of this 8. So this isn't missing all of this denominator. It's only missing part of it. So my least common denominator is actually going to be this first denominator, 8 times 2n plus 1. So then I need to figure out what's missing here to make 2 look like 8 times 2n plus 1. Well, I would have to multiply that by 4 to make it look like 8. And then I'm also missing 2n plus 1. So my first numerator is not going to change. It's still going to be 5. And then my second numerator of 5n is going to have to be multiplied by 4 times 2n plus 1. And that's all over 8 times 2n plus 1. Now you can choose to distribute this however you want. It does not matter. Personally, I would distribute inside here first. So I'm going to have 5 minus 5n times 8n plus 4. And then I'm going to distribute the 5n, and it's negative, so be very careful. Make sure you pay attention to your signs. So this is going to be 5 minus 40n squared minus 20n. And that's all over 8 times 2n plus 1. Now, if I look at 5 and 40 and 20, they're all divisible by 5. And I'm also going to factor out that negative sign because my goal is to see if I can factor it. And it's easier to factor if my first coefficient is positive. So I'm going to factor out a negative 5. So dividing negative 40 by negative 5 is going to leave me with 8n squared. Doing the same thing with 20 is going to leave me with plus 4n and then minus 1 from the 5. And then 8 times 2n plus 1. Now, if I was thinking about my t-chart, I would have 8 times negative 1. So I have to multiply to get negative 8 and add to get positive 4. There's no factors for 8 that would work. So this is my simplified form here. All right, and we've got 2 more. And again, I'm going to let you pause the video, try this one without me, and then unpause and I'll show you my work. All right, so hopefully you actually paused the video. So looking here, focus that up a little bit. So my common denominator is the 2 just multiplied together. The first one is missing x plus 3, so I multiplied by x plus 3. Second one was missing x minus 2. So that gives me 6x plus 18 plus 6x squared minus 12x. Here I combined my like terms, and I noticed that 6, negative 6, and 18 all have a 6 in common. I factored out the 6. This quadratic in here is not factorable, so that's as simplified as I can make my answer. All right, and last but not least, we're actually going to do this last one together. because, zooming out again, both of my numerators in this case are also binomials. So we are either going to have to do the box method for multiplication or FOIL, however you prefer. We're going to have to do a lot of extra stuff in this one. Let's make this a little bit clearer. All right, so my common denominator is going to be those two multiplied together. It's as simplified as I can make it. So 3x plus 1 is going to have to get multiplied by x minus 6. And x plus 2 is going to have to get multiplied by x minus 1. And there's my common denominator. Now, in some of the other classes, you guys might be comfortable with FOIL. I know my classes prefer the box method. It literally does not matter how you choose to multiply. However you multiply, just make sure you get all of your terms. This one should end up with 4 terms if you double distribute. So should this one. And then you can simplify and combine like terms. I'm going to do one with the box method and one with FOIL just so that everybody's bases are covered. So if I do 3x plus 1 times x minus 6, this is going to give me 3x squared x negative 18x and positive 6. Sorry, negative 6 because that's a plus 1. So those would be the 4 terms if you did FOIL that should show up. So that would give me 3x squared minus 17x minus 6 from multiplying these two together using the box method. Now the second one, I'm going to do FOIL for anyone who prefers that. So my first two terms multiplied together is going to give me x squared. X times negative 1 is going to give me negative x. 2 times x is going to give me 2x. And 2 times negative 1 is going to give me negative 2. So now I'm going to combine my like terms. So I'll have 4x squareds. I'll have, this would give me positive 1. So minus 17 is going to give me negative 16x squared. And then negative 8. Oh, and this should not be x squared. This should just be x. Sorry. And then x minus 1, x minus 6. Looking at these, all of those are divisible by 4. So I'm going to do that. I'm going to factor out that 4. So I'll have 4 times x squared minus 4x minus 2. This is not factorable. So that's as simplified as I can make it.